7.3, Euler's number is E. Yes, you'll recognize this as one of the transcendentals that we kind of talked about at the beginning of the year. Just like pi. Pi is 3.14 blah, 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 blah. E's value is 2.71828 blah, 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 blah. These are kind of some interesting facts. The natural base E is known as the Euler number, even though Leonhard Euler did not actually discover it. He just used it a lot in his work. He discovered E by the number that 1 plus 1 over n to the n approaches as n approaches infinity. So let's pick a random number for n. So we're going to make n 15. So that would mean that Euler's is derived by doing 1 plus 1 over 15 to the 15th, which means we're going to do 1 plus 1 15th times 1 plus 1 15th times 1 plus 1 15th, 15 times. That's how E is derived. The last thing, which we've already discussed, is E is irrational, and this is the number, but we are going to simply round to 3, just like we always do, so 2.718. Okay, something else very interesting about Euler's is what happens when you graph. I'm going to very quickly put the graph y equals 1 over x. If I plug in 1, I get 1. 1 over 1 is 1. If I plug in 2, 1 over 2 is 1/2. If I plug in 1/2, 1 over 1/2 is 2. And I get this graph. And if I block off a unit of area underneath the curve, so 1 square unit is a 4 by 4, since four blocks are 1 unit. So if I block, starting at 1, if I block what would be the equivalent of 1 square unit of area, the block will actually come up to about here. And this is a 1 square unit of area under the curve. And this number right here is Euler's number, 2.718. The graph of Euler's, or E, I'm going to refer to it as E, is also growth or decay. In this first example, y equals e to the x is my example of growth. Don't forget, E is a number. So E is going to be my B, A is 1, and B is E. And we learned yesterday that if I graph, if I pick -1, I'm going to be graphing A times 1 over B, and I'm just going to give you that number. That number is going to be 0.468. Obviously, this is going to be on the calculator portion. If I plug in 0, obviously, e to the 0 is 1. 1 times a would be 1. And if I plug in 1, I get e to the 1, which is 2.718 times 1. So this would be e. Now if I graph that, I'm going to get -1. Again, we're going to go and say 4 blocks is 1. And I plot those points, and you can see that that would be growth. In the second example, y equals e to the -x, don't forget, this is to the -1x. So this is actually the graph of y equals 1 over e to the x. And if I were to create a table for that, if I put in -1, it means I'm actually graphing e to the 1x, so this is going to be my 2.718. If I put in 0, I get e to the 0 is 1, so 1 over 1 is 1. That stays the same. And if I put in 1, I'm graphing 1 over e to the first, which we learned is 4.468 about. And that's going to go off my screen, so we'll keep it at 0.46. Again, we're going to use 4 blocks as a unit. And if I were to plot those, -1, which is about back here, 2.7, 1, 2, almost 3, 0, 1, and 1 a little under a half, you can see that this is going to be decay. Okay, so typically, if my exponent is negative in Euler's graph, that would mean decay. If my x is positive in Euler's graph, that's going to give me a growth. Now, obviously, this is going to, something like this would have to be on a calculator portion. For the non-calculator portion, I think you ought to be able to graph e to the 1 power, 1x, or e to the negative x. So you should know that e to the 1 is 2.718, e to the negative 1 is 0.468. But this obviously is going to have to be done by calculator. So for the left graph, y equals 4e to the 1/2 x, I'm just going to, obviously, 0 is going to be 4. Okay, 1 is going to be 6.6. And if I put in -1, actually I'm going to put in 2. I'm actually going to put in -1, and we get 2.4. Didn't draw this graph really perfectly well, so 0, 4, 1, 2, 3, 4, 1, 6.6, 4, 5, 6, almost 7, and -1, 2.4, which is going to be somewhere down here. And you'll see that this gives me a growth. I haven't shifted up or down, so my asymptote is still going to be 0, so y equals 0 is still going to be the asymptote. Now I'm going to switch over here to this one, and again, because e to the -1.5 paren x plus 2 paren plus 4, this is going to be a backward shift of 2 and an upward shift of 4, but we're just going to put this in the calculator and grab some numbers. So the first number I'll grab is -2. Will be about 5. -2, 1, 2, 3, 4, 5. And -1 will be 4.2. 1, 2, 3, 4.2. Not quite there. And 0 will be 4. 4.04, 4.04, which is right above there. And we know that our asymptote is shifted up 4, so our asymptote now comes in right here and skirts right under that. And sorry, I missed some of the points, but you get the point. Okay, let's just make sure we're learning domain and range. Domain, obviously, for exponential growth and decay is going to be all real. Negative infinity, positive infinity. Range is from the bottom to the top, but remember it will never hit my asymptote. That is why I must be not included here. And that's the end of the graphing portion. Please make sure you watch the next really short video on exponents and applications. Exponents, woohoo!